Welcome, Calculus BC. This is lesson 2-4, related rates, story problems. Let's begin. So, a little bit about related rates. So these usually happen when we do word problems. And in these kind of related rate problems, the idea is you're going to find a rate of change with respect to time. So it's going to be like a d over dt thing. So you're going to derive with respect to time, in this case, not with respect to x, of some quantity by using rate of change, so derivatives. So just you're going to use your implicit differentiation skills, and you're going to be deriving with respect to time, even if there's no t's. And then there's going to be a lot of variables that you can either plug in or you got to find. So just a little bit of the procedure, this helps out. Sometimes you want to draw a figure if you're not given one. Like sometimes it's an idea if it's some box and you want to draw a figure of what's going in and maybe like what's coming out. Sometimes we do those kind of problems. Or like if it's a triangle and it's like a right triangle and you have different sides, you want to maybe label those sides. Sometimes helps. Or like sometimes we talk about which side is growing and which side is shrinking in these types of problems. Just like ladders against the side of the wall problems. So you might need to draw the picture out. It might help you. Write down your given information and what you're going to have to find. So what do you have to find? So maybe if you want to find the rate of change of radius with respect to time, write down dr dt. So it's a lot like reading and trying to understand what the problem's saying. Two hints that I think are really good. When you're writing equations out relating those variables, think about which quantities are changing, which are constant. So if it's changing, it's going to be represented by a variable. Just if you read the problem, do you think that number is changing? Like if the height of the ladder is moving down the side of the wall, well, the height of the ladder is not going to change, but maybe like where the top is going to change. Or like if a boat's moving, it's the distance between things might change. If it's a constant, it must be represented by a number. So things that are constant are going to be numbers. Things that change are going to be variables. So always think like, well, is that a number or a variable? And sometimes you have to like figure out what the number is. It's not like explicitly told to you. So you also want to look for secondary relationships. I mean, that means stuff like a Pythagorean theorem if you're looking at a right triangle, or if it's a rectangle, and we're talking about area or perimeter, formulas for that kind of stuff. So usually secondary relationships, a lot of times you use in your geometry or, your trig rules and stuff like that, or Pythagorean theorem. And so then eventually you get to an equation where you have two variables left. So you want to get down to two variables. And then you're going to implicitly differentiate when you get down to two variables, and then substitute all your stuff in, and eventually you can find whatever you're trying to find, dr dt or whatever. And so you should be able to explain what the meaning of your answer. Like if the rate of change, and what this usually means is like difference between negative and positive. If like a rate of change is negative, that means something's shrinking. If it's positive, it's growing. So let's do some examples here. So this is a very basic problem, not really a word problem, but got the basics of what's going on. So it's giving you some information and it's just telling you what you want to find. So I'm given this, usually I'm reading a word problem and trying to read these equations and read the givens. But in this case, here's the givens. Now, and I want to find this, so dy dt. I do have an equation. My equation is right here. And this is stuff I'm going to use to plug in. Now, I want to find dy dt. So when I get to this point, I have the equation, and it's just two variables. I'm just going to differentiate this equation. So you differentiate that. Remember, you're going to have to do product rule here. Well, that's your f and your g. So f prime is going to be 1, and g prime is going to be 1. Well, it's not 1. Remember, it's with respect to time. So gotcha. So differentiating x is actually going to be dx dt, and differentiating g is going to be 1 times dy dt. All right, so let's plug that in. So it's going to be f prime, so dx dt times regular g, so y, plus regular f, so x times dy dt, equals derivative of 12 is 0. Sweet, I differentiated. So let's start plugging in. I know y equals 4, so I can plug in 4 for this. I know dx dt equals 6, so I can plug in our negative 6, so times negative 6 for this. And I want to find my dy dt. But what does x equal? Well, the thing is, we're not told what x is. But since we know y is 4 and x times y is 12, well, I can say x times 4 equals 12. So that means x has to equal 3. So it's 3. So that's one of those cases where it's implied what x is. You just have to figure it out. So now I have enough numbers. Let's start doing the math. So this is going to be negative 24. I'm going to add that to both sides. So I get 24 equals 3 times dy dt. Divide by 3. My dy dt is going to equal 8. Positive 8. And so that means the rate of change of dy dt. So dy dt is 8. One more example, and that's it. So this is like a word problem. A windlass, so a boat, is used to tow, a windlass is used to tow a boat to a dock. So I guess that's this rope? Okay. I'm not sure what a windlass is. The rope is attached to the boat at a point 15 feet below the level of the windlass. So, yeah. If the windlass pulls in rope at the rate of 30 feet per minute, at what rate is the boat approaching the dock when there is 25 feet of rope left? Write a sentence explaining the answer. All right, so there's a lot of things going on. So hopefully this picture, what you have going here is a right triangle. They laid that out for you. And your rope is Z. So we're looking at a few things. So usually looking at these numbers. So we have this distance here. I'm going to call this, well, Y, but it's going to be 15. And if the wind pulls the rope at a rate of 30 feet per minute. So at what rate is the boat approaching the dock when there's 25 feet of rope out? So I know that 25 means Z equals 25. We're looking at that point when this rope length is 25. And then what is the rate of the boat approaching the dock? So the rate of boat approaching the dock is the dock's right here. It's going to be the rate of change of x. So we want to find dx dt. dx dt. And we have this other case. So what is this? The windlass pulls the rope at a rate of 30 feet per minute. So that means dz dt, since that's my rope, is going to be 30. I hope that's that. And that's not something else. No, can't be. So we got enough information. And we know that this is 15. So I want to find dx dt. Well, I got a relationship between these variables. I know 15 squared plus x squared equals z squared. This is Pythagorean theorem. So this is my equation with two variables. 15 squared is 225 plus x squared equals z squared. So now we can implicit differentiate. I know we're going to find dx dt. Implicit differentiation means I'm going to get 2x, this goes to 0, so 2x dx dt equals 2z dz dt. Cool, now let's start plugging things in. Well, I know my z equals 25, so that's going to be 2 times 25. I know dz dt equals 30, so times 30. But I don't know my x. Well, I can use this equation here, and what I know about z to figure out what x is. So let me figure out x over here. We get 225 plus x squared equals 25 squared. Okay, so 25 squared is 625. And we have 225, so I'm going to subtract 225 on both sides. So my x squared equals 400. And you're going to square root both sides. When you square root 400, x equals plus or minus 20, because 20 is 200. So I have two possibilities for x. This is where you got to think real world. These are all positive numbers. We can't have a negative x. So I'm only going to deal with x equals 20. So this might come up. You got to worry about real world. So my x equals 20. I can say 2 times 20 dx dt. All right, so doing some math, that's 40 dx dt equals 50 times 30 is going to be 2 zeros in a 15. So 1500, yay. And then divide both sides by 40. And what you're going to get is your dx dt equals 150 divided by 40. So 150 divided by 40, which is going to be 75 over 2. I'll just leave it as that. And what does that mean for my answer? That means, since it's positive, the boat is approaching the dock at a rate of 75 over 2 feet per minute, because those are our units. That's one thing. So we got to always like watch what our units are when we're talking about that. So it's approaching the dot at 75/2, which is 37.5 feet per minute at that point. All right, we're done.